Weird day today. Water bottle crinkling, F-bombs being thrown left and right. Two honors classes, two F-bombs. I've never seen this before in my life. I don't know what's happening to this generation. Another drink here. All right. Must be the Sahara Desert in here. Anyway. Oh, I got this. This is a different calendar. Okay, so we were talking about Pascal's triangle here for the binomial theorem, which is what we're doing today. Okay, and actually write this stuff off to the right here. But I wanted to talk about Pascal's triangle, and I got in a rabbit hole last year of YouTube. Anyone ever watch regular YouTube, like on TV, and then what you watched and other things that you watched come up? And I got in this whole thing about Pascal's triangle and other uses for it. I don't know if you want to call it uses or not, and other applications, and it got quite weird and wild. As a matter of fact, Pascal, I forgot his first name. I don't want to make it up, but Blaze? Does that sound right? Anyone know Pascal? Anyway, forget it. I think I just made an embarrassment of myself. But he's actually a big time mathematician in general. This is a very small component of the things that he brought up. As a matter of fact, I think in this document from Algebra 2, it talks about him like his birth and death, French mathematician. Man, he wasn't very old either. 62, 52, 42, died at 39. Boy, there could have been a lot more from him, I bet. But I'll just leave it at that. And here we go. This is what we want to write off to the side. Okay, I probably in the bell work should have had you do a plus b to the cubed power instead of x plus 5, so you could see a connection with it. But then I'm going to go back up and do what we did in the bell work and show you using what's called the binomial theorem for the same question, and then be really honest. When would you use the binomial theorem? Probably be fourth power and on. But if you accept with me a plus b to the third would be this answer, then we need to see some patterns. And that's what I said last hour. That's what a mathematician does. A mathematician's efficient. A mathematician tries to find patterns in things so we can do things quickly. That's sometimes what drives me nuts in this department. I don't think we do that sometimes. All right. That's why I like teaching step by step by step. If you just watch and follow, you'll be successful. If you decide not to and you can't, then you won't. All right. Very simple. I think science is very similar. So you have to accept that this is what it is cubed. And then we'll show you the bell work and how this application of this formula works. That these coefficients are actually Pascal triangle numbers. They actually work. All right. And we'll leave it at that. So forget about the 11th row. I think that's a comment I'm going to make later about how do I get to the 11th row of Pascal's triangle. And that's where I'm going to show you a formula. But I do want you to write this because we did talk about the next row, which actually count these 1, 2, 3, 4, 5, 6. That's the 7th row of Pascal's triangle. This is how it would work if you had to take a plus b raised to the 6th. The 7th row of Pascal's triangle would be the coefficients, and this would happen. I'm not gonna make you take a plus b raised to the 6th to see this. It'd be a waste of time. And then notice the pattern in the a's, just like in the cubed. Look up at the cubed. A cubed is the first term, and then notice the a's. They all go what in the next term? They all go down by how many? 1. And then notice the b's. By the way, what's b to the 0? What's b to the 0 power? What's anything to the 0 power? 1. So this is b to the 0, and then what do the b powers do? They go up by 1. Pattern recognition. Okay, so what I could do is recognize this pattern, but then take binomials to any power and exercise this pattern, because the pattern is true. That's a mathematician. All right, and that's why we are going to do this today. You did it last year. Blah, 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 blah. Notice I didn't finish this, but a to the 6th, a to the 5th, a to the 4th, as you looked at these terms. B to the 0, b to the 1, b to the 2, and so on and so on and so forth. And then Pascal triangle numbers, 1, 6, 15, 20, 15, 6, 1 would be the coefficients in front of those. Here's the problem. That's why I had 11th row here. How would I get the 11th row of this? What would I need, everyone? to get the 11th row. This is the 7th row. How would I get the 11th row? What would I need, everyone? The 10th row. But how do I get the 10th row? I need the 9th. How would I get the 9th row? I need and then I need this is called a recursive definition. Can everyone say recursive? Okay, and I do want you to write that down. Hopefully, we are going to do sequences and series later. I don't know if we're going to talk about, I hope we do talk about recursive and explicit definitions. Oop, I gave up another word. A recursive definition is not great. Recursive means I have to rewind to a previous thing to get to the next thing. So for me to get the 20th row of Pascal's triangle, I'd have to do all 20 rows or 19 rows to get to the 20th. And I have to build this whole thing. So we taught you last year, what does that C stand for? The word's right there on the page. Combinations. Get your calculator out, which I told you to do already. If you are taking a long time to get it out, you didn't listen before. I'm going to show you something that hopefully your teacher showed you last year. Let's get that 7th row, which is the 6. And then, and remember combinations, we use that for probability. Do you remember that? I run a race. How many different ways can people finish first, second, or third? Is that a permutation or a combination? Finish first, second, and third when the first prize is $1 million, second prize is $100. Third prize, you get a sticker from Mr. Samuelis. Ooh, that's pretty valuable though. So does the order matter or not? Yes or no? Yes. Is that a permutation or a combination? That's a permutation. I take 3 people with me in this class to a field trip. Does order matter in that, or yes or no? No. So that's a combination. How many different ways that can happen? Order doesn't matter. Combination doesn't. You don't need to remember this. You just hopefully remember where combinations is in your calculator. Type 6. I'm going to do 6C, and I'm going to do 0 through 6 all at once. So follow along. It's in, let me go up here. I like type in the calculator up here. It's in math, and then it's in probability. What's that other fractions? I don't remember what that one does too much. And then it's 3 combinations. Now watch what happens with my calculator. If you have a calculator how many people have just NCR still in front? So 6 and then NCR. You have actually, I'm looking at your calculators. I could upgrade your calculators. Those 84s can be upgraded where you have this showing. And then you actually have a fraction button. Do you miss having a fraction button that some other people have? Okay, maybe we could go over that. And I did talk to the teacher about the blinking light. He's looking up for a document. I need another Inspire, and then I need to connect them and get that turned off. But anyway, now, I hope you didn't work ahead. Second parenthesis, which is braces. I did this with my students last year. I don't know if the other Math 2 teachers did this or not. I think I went into the CARES room and showed her this, so maybe the CARES students saw this. But I don't know. See what I'm doing? Comma 3, comma 4, comma 5, comma 6. What I want is, you need braces because it's going to calculate all these at once, so I don't have to hit C 7 times. I like to hit C once and get them all. I don't think you have to close that brace, but maybe it's just nice to be clean. This does not work with parentheses, so it must be a brace. Press enter. Boom. Wasn't that the Pascal triangle numbers? So what I've shown you, can everyone say the word? I always hit that. I hate the delay on this computer. It drives me nuts. Explicit. Can everyone say explicit? Explicit. All right. Yes, that's an explicit definition. That is a formula that gets me the number. I can get the 20th row of Pascal's triangle by doing 20C. That'd be annoying. 0 through 10. I wish there was a way I could write instead of all the commas. But anyway, I could get the 20th row without having the previous 19 rows. I can define it right away. That's what an explicit definition is. All right, but anyway, here's some other stuff. Like here's a binomial to the 4th. And then I showed some work off to the side for a binomial to the 4th power that says a minus b. You know, just look at it just to prove that I do get these coefficients. 1, 4, 6, 4, 1. All right, so you see their work. This is long. This is annoying. Anytime you get to the 4th, 5th, 6th power, You don't want to be multiplying these binomials out by hand. No one does. And blah, 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 blah. And then notice in this one for a minus b to the fourth, your b is a negative. Notice these terms alternate in signs. You'll see that happen when we actually apply this rule. Okay, so what does this baloney stuff say here? It's really fine. You know, what did we do first for 6? 6c0, right? That's the first term, right? And then this one is raised to the 6th power. Oh, this one's raised to the 0. And then these go down 1, these go up 1. These go down 1, these go up 1, and so on and so on and so forth throughout the thing. All right, and then NC0, NC1, NC2, all the way up to 6C6 if you had actual numbers. And if you had actual numbers, this would be to the 0 power. What's anything to the 0 power, everyone? 1. And then the last term is raised to the highest power, 6. All right, so this is math notation for what the binomial theorem can do for you. Now, let's go back up here and then look at this, and then maybe make a slight connection. Now, I will be honest, if you just had a binomial to the third, I'd probably just FOIL it out. I think foiling out is a little faster. But I did show using the binomial theorem and how you get the same answer. So if you wanted to spend a minute to write that, go ahead. So it would be 3C0, 3C1, 3C2, 3C3, the coefficients in front. But then that's a little wrong because B is actually 5. Now you're going to be replacing a formula with the numbers that represent that portion. So B is 5. So 5 to the 0, 5 to the first, 5 to the second, 5 to the third. That's why we're getting different numbers than what Pascal's triangle number said. Because the coefficients change if I have numbers in front of the x or the y, or the a or the b, or whatever the variables are. And then that could be the notes for the day, but we're gonna get nuts. You want to get nuts? And if you have a scrapbook of last year's notes, these are the exact same because I don't care. I don't want to use the other notes because they're the exact same with different numbers. I just like the progression of this old Algebra 2 book we used to work out of, and giving Pascal some credit and be able to talk about him, bigwig that he is, in math in general. I could zoom in on that real quick, and that's really the construction of how the binomial theorem works. But we're going to get crazy. Do you want to just do one example of this? Is one fine since it's not new? But then 3 more, because I'll do one long one and then we'll go from there. I don't think I want to do this one. Look at your notes from last year. You know what? I don't even think I want to do this one. And actually, what I should do, gosh, I should do something crazy with the powers. Like if these have powers on them, I think you'll be able to deal with it. So hey, let's make it different than last year's notes. Let's make that. Okay, hold on. I need my mouse. You see the paper move? I can't stand that. It drives me nuts. That's because I'm using last year's notes, so I didn't do this thing. Oh, this OneNote. I miss Windows Journal. Please, somebody out there, make Windows Journal back. Make it a thing. Once I lost Journal, I almost lost my sanity. I'm pleading. Somebody help me out in YouTube. Okay, so what did I do? I made this squared, right? Okay. All right, here we go. 6. Didn't we just get those numbers? Let's write it out, though. Let's write. This is going to get bad. Ready? So this is 6C0. What's 6C0, though? We wrote this out. What was the 7th row? Wasn't that 1, right? And then you know what? 6C1, 7C1, 8C1, or 6, 7, 8. Who do we appreciate? Not Mr. Samuels. He's a jerk. All right, and then 6C2. What's the 6C2 number? That was 15. What's the 6C3 number? 20? And then it goes back down, right? 6C4, but I do want those up there. 6C5 for who matches who. 6C5, which is back to 6. And then 6C6, which is back to 1. Oh, is everyone okay over there? Oh, was that your elbow? Who hit something? I just heard something. Someone punched the wall next door? Mr. Cernowski? Wow. Maybe one of his students got on his. Maybe one of the students yelled an F-bomb, and Mr. Stronowski went nuts. All right, so 5x squared. Can't believe teaching in America. You wouldn't believe what goes on. 6 power. And they say like it doesn't even matter. Oh, what? No big deal. What is anything to the 0 power? 1. Okay, now, yeah, you're gonna have to. Could you please give me the calculation of those numbers? What's 5 to the 6th power? Was it 3125? Oh, I wasn't even close. Go ahead. What was the number? 15625. X to the what? This is why I added this. I changed the notes a little bit from last year. X to the what? 12. You're supposed to multiply those exponents. By the way, this is 1, so it's just 1 times 5 to the 6, x to the 12th times 1. So it is just 5 to the 6th power. All right, next, 6 times 5x squared. I probably should zoom in on this as I go and build these. To the 5th, and then unfortunately it's negative 3y to the 1st. I have to start incorporating that. So what you need to do is get 6 times, and then what's 5 to the 5th? I mean, you could probably do this all at once, but I'll construct this for the notes. What's 5 to the 5th? That's a 3125. And then that's x to the 10th. And then this is negative 3y. And I actually forgot the y last hour. But you got to multiply these numbers across. And then what are those 3 numbers multiplied together? By the way, you're going to have a negative, so I'm going to make this minus. And then what does that become? 3, 5, 6, 2.
5, 6.
Okay, you got to start over. So what is it? What's
5,
after this?
6.
Wait, 3?
5.
5?
No, 3.
You said a 3 first. I know you
He
did.
said 3.
Okay, let's start over. 5, 6, 2, 5, 0. This is a great YouTube video. This is going to be viral. Let's read that guy that can't listen to students says they tell you, shut up. All right, y. Right, y? Y to the 1st? Okay. All right, then next. 15. Yeah, it's a bugger. It's kind of a pain. 5x squared. You'll be better than me, like what I'm saying here. You'll be able to calculate these. I mean, honestly, this is what I would do. Negative 3y squared. I would say, okay, I know I have an x to the 4th, and I know I have a y squared. So I just have to take 15 times 5 to the 4th times 9. I mean, negative 3 squared is 9. If you don't know that, there's the door. Get out. All right? Okay, what's 15 times 5 to the 4th, which is 625 times 9? What does that become? Can you just read the number like a number? No, that's not like read.
84,000.
There you go. There you go. That's better for me. All right, and then 20, and then times 5x squared. He'll be faster than I am here. Negative 3y to the 3rd. So this would be an x to the 6th and a y to the 3rd term. Hopefully I'm doing my terms correctly there. And then it'd be 20 times 5 to the 3rd is 125, and then negative 27. So it's going to be minus, and then what's the big number? 500?
Yeah.
Nice. Now we're moving. And then 5x. Good thing we're only doing one of these. Everyone okay out there? $15. 5 squared is 25. And then this is 3. This is 81, right? So it's really, and then it's x to the 4th, y to the 4th. I literally would just get my variables and then just, get the constants taken care of. What do you get for that one? 375 at the end. Good. That's the term. And then this is 5x squared raised to the 1st. And then negative 3y to the 5th. What is it? That's negative 243. So that's 6 times 5 times negative 243. And then it's x squared, y to the 5th. What do you end up getting? 6 times 5 times negative 243. Minus, get the minus out of the way. Everyone okay? Following along? Those are the numbers. And then I really don't have to write this, but 5x squared to the 0 is just 1. That's a 0. And then negative 3y raised to the 6th, which is y to the 6th. And then 243 times 3, that's a plus. Thought I got this last hour. 640, 729. Hey, yo. Okay, monster. Oh, boy. If you say, I don't get any of this, I'm going to hit my head up against a wall. Go ahead. Yeah? 1, 2, 3. Third? Yeah, you're right. That's x to the 8th. Nicely done. Okay, and then, I should check. Look at a pattern. What's wrong? What's this? You all right over there? No, okay, 12, 10, 8. Okay, 6, 4. Yeah, so maybe double check your pattern on that. And then 0, 1, 2, 3, 4, 5, 6. Okay, so yeah, notice the pattern on that too. Pattern recognition. Ooh, okay, so I guess that's good. I like these questions better because that's not fun. All right, that takes a long time. These are better. So, you know what the first term is? First term is 10. 10c what? What's the first term? 10c what? 0. So what's the fifth term? 10c4. Okay, 10c 0, 1, 2, 3, 10c4. So the fifth term is 10c4. I love these because I get the pattern, I get the idea. Do I really have to expand? This would be 11 terms. Oh my gosh, that'd be a sadistic thing to ask. And then 3x and negative 2y. And understand that these have to be multiplied. And then this is how I teach my students. I say, you know what? Look at a pattern here. Look at a pattern in every single one of these. 10c2, that's a 2. 6c4, and that's a 4. Nice. Bottom of it? Okay, good. We got the solution for that inspire. So what I'm trying to say is that this is a 4, and then notice what these add up to become. So what should this one be? What should that one be right there? 6. Okay, and that's it. That's how I get the fifth term. Then, of course, I have to calculate all these numbers. I have to do 10. Can you imagine having to do Pascal's triangle for a 10th power? I need, the 11th row, and then that's where the problem is. We want to know this 10c4 thing. Gosh, I think the other ones are, they're not doing Pascal, or they're not doing combinations. That's going to be a problem. What's 10c4? What do we get for that? What is it? Huh? And then I'm old here, all right? So you're going to speak up. And then 84 times 3. Did we just have this? Is that 729 again? So this is 729 x to the 6th. And then this is, that's easy, that's 16 y to the 4th. So what's the fifth term of this binomial expression or expansion? It is x to the 6th, y to the 4th. And what's 210 times 729 times 16? These three things multiplied together. Verification, what'd you get? Woo! Mr. Samuels' bank account. Nice. Anyone else get that? Can you imagine multiplying that out by hand? I had fools try to do that. Yeah. Do we need to do this one? No. I want to do this one though, and it can be harder. Be careful. This is why I added. Be careful if there's powers on there to make this match. Using your exponent rules. So I wanted to do that once. I'm sure in the homework they do that. Expand it a little bit, make it a little bit tougher. But here's what at least I know. I know it's going to be 8c blank. I just got to fill in that blank, right? So I'm going to put these blanks here, and I know it's going to be 2x raised to some blank, and I know it's going to be 5y raised to some blank. Well, I mean, this is easy, all right? What would this have to be? So I'd have the x to the third. What would that power have to be? 3. And what are they supposed to add up to become anyway? So what's this power got to be? Should have made a bigger circle there. And then technically, what is this supposed to be? Even though you're going to be okay, I'll tell you why. What number should that be? It's either 3 or 5. Which one should it be? It's supposed to be 5. You'll be lucky though. Notice Pascal's triangle, it goes up and then goes down and it's mirrored. It's a symmetric thing. 8C3 equals 8C5. It's guaranteed. All right. And then we don't have to do the calculator online anymore. Okay. You find 8C5, you find 2 to the third, you find 5 to the fifth, and multiply it by whatever 8C5 is. That's the coefficient. That's the number in front of the x cubed y to the fifth term. Don't need to do that online. Okay, we'll call that a video. So